Good afternoon, pilot teachers and students, and good afternoon, class. All right, sit down. All right, I will quickly go through what we discussed in our last lesson, and that is on nuclear fission. Right, basically in nuclear fission, you find that the nucleus will be splitting up into two different elements. But and then you find that before it splits up, it must firstly receive a neutron. When it receives a neutron, the mass has to increase. Okay, you can simply find it out on the mass numbers of these nuclei. And then after receiving that neutron, it must break up, forming two different elements. And then on that note, it must also send out let's say two or more neutrons. Okay, that is what we studied, especially on nuclear fission. Now in this lesson, we will be going through on nuclear fusion, which is the opposite of nuclear fission. So can somebody explain the opposite of nuclear fission, which is the nuclear fusion? Joe, can you explain nuclear fusion?
The joining of two or more light atomic nuclei to make a more massive one.
All right, very good. So it is the joining of two light nuclei to form a much more heavier one or massive one. Okay, looking at this, right here is the definition of nuclear fission, fusion. Now, this process can also send out a large amount of energy as well. And it is happening basically in the sun and the stars, right? As the sun is also one of the stars, and also the stars as well. So this nuclear fusion is happening in the sun and the stars. That is where the hydrogen isotopes, which are deuterium and tritium, okay, they are combined to form large amounts of energy. So what you can do now is to quickly copy the definition of nuclear fusion, and then there will be also some other notes on this topic. And after that, I will give you a few activity questions based on the topic. Okay, so quickly go through and then have this down into your exercise book. All right, the additional information given there is the difference of these two masses before and after reaction is given as a form or in a form of energy. Okay. We will go on to the next slide. An example given there is for hydrogen. All right, the nuclei of this hydrogen, which are those are isotopes. Okay, one of the isotopes of hydrogen will be deuterium, and the other one can be tritium. Now, looking at the helium, that is helium-3, and the neutron. So the isotope of hydrogen are H2. Okay, normally you find that H2 and H3. Okay, there is a common one which appears as a natural abundance, that is hydrogen 1. But these ones are 2 and 3. So the 2 is known as the deuterium, and the other one will be tritium. Okay, this is the common one, but then there are two others. Okay, that is known as this one is the we shall move on to all right, that is one example given for hydrogen, that is especially deuterium. All right, if you can look up from that example, I'll explain to you and then I'll give further explanation on other notes. Right, because you have this, okay, that is fusion. Since we have this, which is two of the deuteriums which combine to form these. So because of these two and that two, gives you 3 over here, and this 1 and 1. So if we decide to place this one as hydrogen, helium, then you will find that this is almost equal to these 2, and that is 3. So it has to have 1 neutron to balance this out. 1 plus 3 will give you 4. And this one will be 1 plus 1, which will give you 2. Or we can have it as this, which is hydrogen 3, and that is tritium. Then you have 3 over here, then 1 over there. So in order to balance this, because you have only 2 over here, we will have this one as H1, okay? Because this and this will give you this and this, which is 2, and this plus 3, the 3 over here will give you 4 and that, okay? Quickly copy this example and then I'll give you some activity questions, okay? All right, we will. Okay, that is one example of nuclear fusion. It is happening in the stars and the sun, and you have the solar energy which is received by us on Earth because of this nuclear fusion. Okay, we will move on to the last piece of information. Okay, that is a mass defect is simply the mass that is lost. So you find that the mass defect of the reaction is it is less than the mass defect of the product. So meaning that the mass of the two reactant will be less than the mass of the product. Okay, these are your questions. You have to write a balance equation for each one of those reactions. Okay. Number one, you find that there is something missing from that question. So you're placing that missing information, and then for number two as well. So each one of those four questions are fusion reactions. So quickly copy those four questions, and then you fill in those missing spaces. Okay, should be HE. Question number 3. Alright, for this question here, that is okay. Only for question number 2 you put helium. Okay, it should be helium 3 over here. Okay, so you put helium. It is not hydrogen but helium. Alright, for question number 3 is okay. Question 3 is okay. And question number 4, all right, that is still okay. Where? Which one? Question number 4. Okay. This one is also helium. Okay, He4 over 2. Okay, only this and this He3 over 2. This one is He4 over 2. If you have any questions, please raise your hands. Where? Yeah. For the neutron, the 1 should be on top. Okay, you have the 0 below. Okay, you just have the 1 on top for the neutron. This one should be 1, and then 0 will be over there. What's this? Okay. Your question 1. Question 1 will be you. Like the question number. Question 2. Question This is 3. Okay. Okay. Garrett. Question number 2 is yours. 1, 2, 3. Okay. Amanda. Question number 4. Question 4. All right, quickly finish those questions. Answering them, I will ask those students to come up and then show you answers. All right, who has some difficulty with it? You okay? Are you okay with your... All right. Are you finished? Are you finished? Okay. Okay, when you explain that, probably you can include energy in here. Some form of energy in the form of heat is given off. Question 2. All right, I will now ask each one of you to come up, those students who are chosen to come up and then show your answers. Please to come up quickly, write your answers, and then you do your explanation on that answer, and then you can go back and the next person will come. So our first question, that is question number 1, failing. Write your answers down nicely, and then you do your explanation, go back and sit. One should be on top. If you have made a mistake with that one, the one should be on top, 0 should be below for neutron.
Given that this is hydrogen 3, 1 and hydrogen 1 and 1, it says to find this, the unknown is this, so 3 plus 1 gives 4, so if there's 2 there, then 2 should be here. So there's 2 here. This is 1 and 1, so 1 plus 1 will give you 2. 2 on this side, so this is hydrogen to 1 plus hydrogen to 1 is equals to hydrogen 4 and 2 plus energy. Energy is given out in a form of heat.
Class, is that answer correct? Yes. All right. We'll have question number 2.
for second question.
All right, the answer for second question, you have two deuterium, which forms a helium plus a neutron, so the mass will be balanced out. All right, that is the answer. Question number, the third question. Was asked the question for you.
In this case, hydrogen 1, hydrogen plus hydrogen 2 plus hydrogen 3. The mass numbers on this side, they add up to 5, and the atomic numbers they add up to 2. So to balance, on this side you have a neutron, and to balance the equation out, you add an atom of helium. So that will be 4. The mass number is 4 and the atomic number is 2. So 4 plus 1 will give you 5, and you have 2 here plus 0, so that's 2. So then that balances out the fusion reaction.
Okay, very good explanation for that question. That is quite correct. Okay, we'll go on to the last.
Because the mass number of the product is 5 and the atomic number is 3, we need to balance the equation. So we add helium 3 and 2 to balance the equation. So the mass numbers are 5 and the atomic numbers are 3.
Okay, again, very good explanation when you have to have this, right? Since we have this one, that is 4, and 1 over here, that will be 5. So you have to balance this out by having a helium so that you have 5 on this side on the reactant, and then you have 5 on the product. And from this, there are 2, 1 is 3, plus 1 of this. So you have 3 on this side and 3 on that side for the proton, and you have the mass the same. And also in here, right, the energy is released. All right. So those are our answers to the 4 questions. Basically, looking at nuclear fusion, that is when you have to combine 2 light nuclei to form a much more heavier one. And on that note, it also releases some amount of energy. And nuclear fission or fusion can also be happening in a nuclear reactor, especially when people are trying to produce power or electricity. You can use fusion or you can use fission. Right? Those 2 processes can simply happen. But naturally, we'll find that the fusion process is happening in the sun and the stars, okay, in which they have to produce large amounts of energy. And looking at the mass defect, you'll find that the product will have less than the mass defect of the reactants. Okay, so that brings us to the end of the lesson. Our key phrase will be nuclear fusion. Good afternoon, fellow teachers and students, and good afternoon, class. All right, sit down.